Good afternoon everyone, I am Josephine Candilada and today I will be discussing my topic which is orthographic projection. Ang orthographic projection kay a way of representing a 3D object into a 2D drawing, like a paper without perspective, meaning dili na to makita ang depth pero accurate ang size and shape sa object. In orthographic projection, ang mga projection lines kay perpendicular or 90 degrees projection plane. Mao ang true size ang makita sa matag view. This is why orthographic projection is very important sa mga engineering, architect, and technical drawing. So there are three primary views in orthographic projection, which is the front view, the top view, and the right side view. Kining tulo ka views kay magtinabangan sila para mahulagway sa ka 3D object bisan 2D ra ang drawing. So if the object is titled or not parallel, the main planes the drawing is called an axonometric or axillary view, such as isometric, dimetric, and trimetric projection. So, in simple terms, orthographic projection is important because it helps us show the exact shape and the size of the object clearly and accurate.
Good day everyone, I am Kurt and my topic is multi-view drawings. A multi-view drawing is a way of showing an object using several 2D views. Instead of drawing the object in 3D, we break it down into separate flat views so the measurements become accurate. The three main views used in multi-view drawings are the front view, the top view, and the right side view. Each view shows different dimensions of the object. The front view shows the width and height. The top view shows the width and depth. The right side view shows the height and depth. By combining these three views, we can clearly understand the object's exact shape and size, even if it is drawn in 2D. This is why multi-view drawings are important in drafting and engineering, because they make objects easy to measure, build, and understand. That's all.
Complex object visualization. It's basically the process of using visuals to understand and analyze data or object na super intricate like dagan kaayo components and relationships. Think of it like you're using charts, graphs, and even interactive 3D modern to simplify complex datasets para dali ra makita ang patterns, trends, and outliers. It can also mean using techniques to render complex geometric and physical phenomena like virtual reality environment para dali ra siya ma-perceive and ma-interpret. Now, there are different applications and techniques. First, there's data analysis. Imagine translating vast and complex datasets into visual graphics. This helps users to identify trends, relationships, and outliers na lisod kaayo makita in a raw of data. This is especially important karon na we're in the era of big data. Then there's geometric and scientific visualization. This is about creating visualization of complex mathematical objects like non-orientable surfaces or 4D objects para ma-understand nato ilahang properties. This can involve using graphic processors and structures to render combinations of translocate volumes and surfaces. We also have computer-aided or CAD and virtual environments. This is about developing methods for capturing, manufacturing, and rendering complex physical objects in virtual environments for scientific study and design. And lastly, there's cognitive support. This is where we use external representations like interactive visualizations to support human cognitive demands when making sense of complex objects and activities.
Good day everyone, I am Regine Bacchus and I'll be tackling about complex object visualization. Complex object visualization uses 3D modeling, 3D CAD, and advanced graphic processing to represent objects in 3 dimensions, making it essential in fields like engineering, design, and science. It also includes breaking down complex structure into simpler visual components like cross-section, layerings, and exploded views to reveal internal parts and clarify how different elements interact. For, for data visualization, tools such as scatter plot, line graph, and bar chart help illustrate relationship and trends, while specializing methods like domain coloring allow the representation of complex mathematical functions in 4 dimensional space. Additionally, tools and programming script automate the visualization of detailed object structures or hierarchies, improving efficiency and enabling more interactive exploration of large and intricate systems.
Good day everyone, I am Ems Venenoso and we will gonna talk about multi-view orthographic exercises. So of course, as we all know, an exercises is a practice activities. So, what multi-view orthographic exercises involve? Orthographic projection basics. Orthographic projection is a method of depicting the 3D objects in 2D by projecting its features onto perpendicular planes. Common views. So there are 3 common views, which is the front, top, and right side. Sometimes left, rear, and bottom depending on the complexity of the object that you're gonna do. So there are exercise types. First is identify views. Matching a 3D isometric drawing with its correct orthographic projection. Second, sketching missing views. Given 2 views, for example, front and top. Sketch the third, for example, the right side views. So that's it. Fourth is aligning views. Using construction lines to ensure future line up correctly across different projections. So, fifth, dimensioning practice. Fifth is dimensioning practice. Adding accurate measure to orthographic drawings. Sixth is conversion task. Translating between isometric 3D and orthographic 2D representation. So what are the skills that we gonna develop by multi-view orthographic exercises? The first one is spatial reasoning and visualization. Second, precision and technical drawing. Next, understanding of engineering graphics standards. Last, ability to communicate design ideas clearly. Let's have an example exercise. So we have here an isometric. So let's draw the front view, top view, and right side view using orthographic projections. And use light construction lines to align features and heavy lines for visual edges. And lastly, add dimension to show exact measurements. So again, this is the given isometric drawing, and this is our multi-view orthographic drawing. The front view, right side view, and the top view.